Okay, in order to find the inverse of this log function, my first step is to rewrite g of x to be y. So I have y equals log base 4 of x minus 3 minus 7. My second step is to then switch x and y. So now I have x equals log base 4 of y minus 3 minus 7. My next step is to then isolate for the logarithm. So I will add 7 on both sides. This will leave me with x plus 7 is equal to log base 4 of y minus 3. I will then convert this to the exponential form. So this will turn into 4 to the power of x plus 7 is equal to y minus 3. I will then add 3 on both sides. This will leave me with 4 to the power of x plus 7 plus 3 is equal to y. So did I get y to be all by itself? Yes, I did. So my next step is to then rewrite this to be the inverse of g of x. So I have the inverse of g of x is equal to 4 to the power of x plus 7 plus 3. Okay, let's go ahead and box that in. Moving on to the next question, we have to find the inverse of the following exponential function. My first step is to rewrite f of x to be y. So we have y equals 3 to the power of x minus 5 plus 4. My next step is to then switch x and y. So I have x equals 3 to the power of y minus 5 plus 4. Then I will isolate for y by subtracting 4 on both sides. This will leave me with x minus 4 is equal to 3 to the power of y minus 5. I will then convert this to the log format. So I have log base 3 of x minus 4 to the power, equals the power y minus 5. From there, I will then add 5 on both sides, plus 5 plus 5. Keep in mind that the 5 right here does not correspond to the x minus 4, so that will be outside. So I have log base 3 of x minus 4 plus 5 is equal to y. So did I get y all by itself? Yes, I did. So my final step is to simply rewrite this as the inverse of f of x. Okay, let's go ahead and box that in. Moving on to the next question, I have log base 5 of x squared minus 11 equals 2. My first step is to convert this to the exponential form. So I have 5 to the second power is equal to x squared minus 11. From there, I will then simplify this further. 5 squared leaves me with 25 is equal to x squared minus 11. I will then subtract or move all the terms to the side that contains the positive x squared. In this case scenario, I will subtract 25 on both sides. This will leave me with x squared minus 36. Now keep in mind that this is a perfect square, right? We have x squared is a perfect square. X times x gives us x squared. And we have 36. 6 times 6 will give us 36. And we have a difference, right? We have subtraction, so it's a difference of squares. So what do? We take the square root of the constant 36, and that will leave us with plus or minus 6. From there, we have our factors. Let's go ahead and write them down. We have x plus 6, and we have x minus 6. From there, we have what? X plus 6 equals 0, and we have x minus 6 is equal to 0. And from there, we isolate and solve for x. So for the first one, we get what? X equals -6 as the final solution. For the second one, we get what? We add 6 on both sides. We get x equals +6. Okay, moving on to the next question, we have the following log equation. My first step to solve it is to convert this to the exponential format. So I have 3 to the power of 4 is equal to 2x minus 6. I will then simplify this further. We know that 3 to the 4th power will leave us with 64. So we have 64 is equal to, let me just double verify that real quick. 3 to the power of 4. Oh, excuse me. It's an 81, not a 64. My apologies. So that's going to be 81 is equal to 2x minus 6. I will then add 6 on both sides. This will leave me with positive 87 is equal to 2x. I will then divide both sides by 2. So I divide this side by 2, this side by 2. And this will leave me with a final solution of 87 divided by 2 as my final solution. We cannot simplify this any further, so leave it in that format. Okay. Moving on to the next question, we have to go from a description to a function. We have write the log function with a base of 3 reflected over the x-axis, vertically compressed by a factor of 1/5 and shifted left 2 units and down 4 units. So for this one, we have y is equal to negative, right, because of the reflection, 1/5 because of the vertical compression, and we have our log base 3 of, and it's shifted to the left, so we have x plus 2, and it says down 4 units, so we have minus 4 outside. And this is going to be our final solution. Moving on to the next one, we have to write the function for a log function with a base of 2, shifted right 7 units and up 6 units. So for this one, we have y equals, we have log base 2, we have shifted to the right, so it's going to be x minus 7. Then it's a shifted up 6 units, so we have what, plus 6. And this is going to be our final solution. Okay, let's move on to the next idea. So for this one, for this function, we're given y equals log base 4 of x minus 2 plus 1. My first step is to identify the domain. How do I identify the domain? I just simply look at the terms within the parentheses. And I set them to be greater than 0. So I have x minus 2 is greater than 0. I then solve for x by adding 2 on both sides. This will leave me with x is greater than 2. And I write down all 3 notations. I have the inequality notation, x is greater than 2. We have the interval notation, which is given to us by 2, comma, positive infinity. We have the set notation, which is given to us by all x's, or for all x's, in which x is greater than 2. For the range, we know that the range of all log functions, it's going to be from negative infinity to positive infinity. And the set notation is given to us by all y's, in which y is going to be an element of the real number set. And finally, we also have the description, all real numbers. Okay, then for the vertical asymptote, we'd simply take the terms that we have inside the parentheses, x minus 2, and instead of setting it to be greater than 0, we set it to be equal to 0. From there, we then add 2 on both sides, and this will leave us with x is equal to positive 2. From there, we then sketch this on the coordinate grid. So we have our vertical asymptote that will always go first. Keep in mind that all of these little squares are going by ones. So we sketch our vertical asymptote right here. Okay. Then we're going to sketch at least 1, potentially 2 points of accuracy. Let me go ahead and graph this on Desmos real quick. Base 4, and then we have x minus 2, and then plus 1. Okay, 3. Okay, so we have 1 point of accuracy at 3, comma 1. So this is 3, comma 1 right there. Let's see if we have another one. We have another one at 6, comma 2. This is 6, comma 2. And let's see if we can fit one more in. Nope, we cannot fit more. Okay, and then from there, we connect our points. It's a smooth curve. It doesn't have to be fully accurate, where you just want to get a rough sketch. Okay, there we go. We're going to put arrows on each end to indicate that the graph is continuous. Okay, now moving on to the next question, we have a local graphic design firm purchased a series of high-performance rendering workstations for $28,000 in 2022. Due to the rapid release of new GPUs and hardware depreciation, the value of these workstations is expected to decrease at a steady rate of 16.5% per year. Okay, write a function v of t to model the value of the workstations, where t represents the number of years since the initial price. Okay, so my first step is to label. This 28,000 right there is going to represent my A value. This 16.5% is going to represent my R value, but keep in mind that we're going to convert this to be a decimal value. So this will give us 0.165. From there, we will then see that this is a decreasing function, a decay function, so I will do 1 minus R. So we go to our calculator, and if we type that in, let's see, 1 minus the 0.165, that will leave us with 0.835. Okay, now that we have everything, we're going to write this down as a function. We have v of t is equal to the $28,000 that was initially spent, parentheses, times the rate that we're working with, 0.835 to the power of t, and that's going to be your function. From there, it's now asking you to estimate the value of the equipment after 4 years. So this is going to be my t value. They're very specific about this one, and they want you to round the answer to the nearest dollar. So we have what? V of 4 is equal to 28,000, parentheses 0.835 to the power of 4. Now keep in mind that when you're entering this into Desmos, we just need this part, the right-hand side of the equation. Okay, now let's go ahead and type that in. If we type it into Desmos, let's see what we get. 28,000, parentheses 0.835 to the power of 4. Okay, if we type that in, and if we round to the nearest dollar, this will be, V of 4, is going to be approximately $13,611 after 4 years. All right, final question. We have to estimate in what year, okay, very specifically, what year the total value of the workstations will first drop below $10,000. So on Desmos, what I'm going to look for is the point of intersection between the line y equals 10,000 and y is equal to the original function above, 28,000, parentheses 0.835 to the power of t. That's what I'm looking for. I'm looking for that point of intersection. And let's see if we type it into the calculator. And it's going to be a very large number, so you do have to zoom out quite a bit. Okay, there we go. Let's see. Okay, so we got the point of intersection. The point of intersection, when rounded to the nearest hundreds place, gave us t is going to be approximately 5.71. But if we round that to the nearest year, this is going to turn into 6 years. Okay, now From there, we then add this to the initial time frame. So the workstations were purchased in 2022. So we have 2022 plus 6, and that will give us the year 2028. So what does that mean for us? It means that at the year 2028, the workstations will go from a value of $28,000 all the way down to $10,000.